We've made it to our next to the last unit here, 14.4, and we are going to use integration techniques that we've already learned, and we're going to apply it to finding producers, consumers, and producer surplus. We're not going to worry about continuous income streams, but just a surplus. And so that means we're going to sell items at a cost, at a price, probably less than many consumers were willing to spend. So that's saving money in the economy, and the consumers, they have more money to spend. On the producer side, they're charging a slightly higher price than what they would be willing to sell it for at sort of at a minimum. And so they get, because there's a higher demand for some reason, they're able to sell a little bit higher. They get a surplus. So that's the producer getting a surplus. The concepts we're going to use are Riemann sums, which we thought, so that's the basis behind what we're doing, along with area between two curves. So let's go ahead and get started and see how this works. But it's the previous couple units where we did area between two curves, and then going back to Riemann sums. That's what we're going to need to understand. So consumer surplus. Again, what this is we've got a general demand curve. And so what's going on here, and this actually, I looked up in the textbook. We do have a textbook. There's an ebook, and you look up, it's pretty much the PowerPoints that they give us. So as we go through these, we've been going through the textbook. But there's some initial price that some early adapters would be willing to pay for a new product. Others won't be willing to pay. So Q, this is the demand of people buying. There'll be more people who buy it as the price comes down. That's a general economic principle. And again, you guys know that better than I do. I never really got into economics much. I should have, but anyway. So the price at some demand level, P is the unit price, and Q is the amount of demand that they can measure. Now and again, it's measured in annual sales. So you can't tell the day that you release a product what it would have sold for. You have to get some data. That's how this is. Okay. So the idea is that if we sell it, say instead of selling at this initial price, if we sold at some lower price, there is this extra money that's in the pockets of consumers. So let's go through that part. So this kind of just talks about it. That's what I did. There's, your early adopters, they want the stuff, the technology, they'll pay a higher price. And usually that's the people who have more disposable income. $100 is not the same to all of us. Some people say, oh, that's just, pocket change. A lot of us, that's what gets us through the week or the month. So those who have that extra money are willing to spend it. And again, go through this. As we drop the price, more people will pay, and that gives you some particular number of units that could be bought. Okay, so we're going to, let's go to the graph. I always like explaining on the graphs first. This is here for you to read to understand a little bit more. So what's it saying is to find sort of the willingness to spend at some price. So Q price. We can use Riemann sums, because remember, area under the curve, if you just one point doesn't really have any area, you need 2 points to get area. So we partition from 0 to Q into so many subintervals, and here's one subinterval. Doing Riemann sums, here would have been another one, right? So we could do these Riemann sums. This one would have looked like this, sort of, kind of a mess, but we'd have all these Riemann sums. And what it all is telling us is we've already done this. If you take a lot of these, so again, this is all just saying using the Riemann sum thing. So it's is forming the basis for everything. But since we've already done this, what we're able to do is we're able to jump. Yeah, it's really just the integral. We don't need to relearn Riemann sums because that was something we went through. We understood it, make it pieces, but we have much more accuracy when we actually integrate. So we're going to integrate from 0 to PQ, to Q bar, which Q bar is some arbitrary amount. We want to sell that many. We want to reach this many consumers. Well, to do that, notice they're going to have to lower the initial price. If they want to do that right off the bat, they're going to have some kind of a price here, which we can call P bar. So this gives them at this price, they'll reach this many people. And again, the next one will make it look more professional. But what ends up happening is if you lower the bar down to here, the price, this is what consumers are paying, and up here in this triangular area was actually what they were willing to pay. So this is our surplus. This is money still in the pockets of the consumer. So hopefully they'll go spend it on something else or accessories or something else. That's what they're hoping for. But the reason businesses do this is they want to sort of get critical mass. They want a lot of people using their product right away, because then they know that maybe the way things happen, they can change this demand curve. If they get people out there, hey, this is really cool, everyone should have one, then the demand curve changes. And these people who wouldn't have paid that much, maybe what's going to happen is this is able to go like this, and now we get some producer surplus. So we get to that point. Okay, so that's what it is. So how do we calculate this mathematically? We're going to keep moving on with this. Again, all of this so far is really the theory behind it. We'll see that we've got the mathematical tools already to do all of this. Okay, so this is the picture of what I just did. Is if we do it at this lower price, we will reach all of these people. We will have the demand we wanted, Q bar, whatever that is set at. And again, up here is the consumer surplus. So when we're calculating it, we're actually calculating the area under the curve minus this, right? Area between two curves. Again, I'm jumping a little bit, but the area here is P times Q, right? The height is our P bar times Q bar. That's this part. It can also be arrived at by getting the integral of P bar, which is a constant. Whatever that price is, it's a number. And so that's a y equals this number. That's also, so here's another way to get it. Okay, and this is what we're going to want to remember. I'll bring it, you'll see it on the next slide as well. But this gets us to the next step that makes this really just a subtraction, right? We're going to get the area under this curve, and we're going to subtract this, the area under this curve, right? So it really, you're going to see is d of q minus p bar. It's a pretty simple formula. We took all this time to get here, but that's why the picture really does it for us. So, and again, this is just words saying what I already said. The difference between what consumers are willing to pay and what they actually pay is money in their pockets. That's the consumer in the surplus, right? So we've got the demand, some function P equals D of Q. The selling price is, we're going to be given that P bar, and we're going to have to calculate Q bar is what we're going to do as a demand. So, and again, remembering that D of Q bar equals P bar. So we'll go through that. That's our consumer surplus. So here's the formula. Boom. Consumer surplus, D of Q dq minus this, which is, remember, it's just an area. And this, remember, equals the integral here. And I'm going to click that in, right? This part here is really an integral. Okay, so right the way they got it, it's not this. So it's dq minus p bar. Okay, so this is what you need to remember for consumer surplus. You're going to see for producer surplus, we sort of just switched the area because we want the area above the curve that we're able to get. So you remember these two things, area between curves and sort of Riemann sums. You don't have to remember so much, just remember that that was the motivating factor mathematically for doing this. But area between the curves, consumer surplus, we're getting the area of the curve above the rectangle. Okay, so that's why we take the area of the curve minus the rectangle. That's what we want. For producer surplus, it's the other side of the desk. They make money when they sell it for more than what people would be willing, but more than what they would be willing to pay to sell it for. So yeah, I'd sell it for $10, but hey, people are buying it for 15, so why not? Okay, so there we go. This is consumer surplus. So let's do an example of a problem, and hopefully all my I can't remember if I fixed my animation, so things might be a little out of order. If they are, I'll fix them. Okay, so what we're trying to get, this here is the consumer surplus. Right, that's money left in the consumer's pocket because they got it to buy it at a lower price. Okay, so D of Q minus P of Q, which is when we're doing integrals. So this area minus this, well, actually the big area, right, the whole area under the curve minus the rectangle leaves us with the surplus. Okay, so here's an example. We're given the function, and in the homework problems you will be given P. P equals this function. Okay, so remember the other part we need is we need P bar, and here it is. We're actually going to sell them for $5 each, which we'd have to plug this in, but is that less than, well, we could graph this curve if we wanted to, but we really don't need to, because in the homework they will also give you P bar as a particular value. So, and we're going to assume that it's lower than what the initial people were willing to pay for it. Otherwise, there is no surplus. Okay, but we can make that assumption. You could also graph these and you'll see it. And in fact, actually, that's how I'm going to go about solving these. Okay, so yeah, we're a little out of order. This is sort of like the answer down here. So what we need to do is we need to get Q bar. Well, what is Q bar? Q bar is the value of the function that would give us P bar. Okay, so P bar is 5. So we solve the equation for Q. Now we could do this either by hand, or we could actually just graph with a graphing calculator, graph both of these. Let me just show you that one, because we're going to come back to this anyway. So we'll take 15 e to the minus 0.01 x. That's what we're using for Q. That's one graph. The other graph is 5. 5, remember, in this case, P is going to be our Y value. So I'm looking at my window. I should probably let my Y go from, let's say, 0 to 20. I'm just guessing at this point. And X is going to be our Q, which is how many we will sell. Let's go for, I'm just guessing 30, from 0 to 30. Let's see if that gives us enough. It doesn't. So 30 only got us to here. I want to see the whole picture. Let's go to 75. 75. Maybe we got to go to 100. Yeah. Okay. But I want you to see this is that I don't have a necessarily, yeah, it's right at about 100. So we're going to go a little bit bigger. Let's go for 125. Okay, so this is the way when you use your graphing calculator, you just have to keep going. So this is where our Q bar is at that intersection point. I'm going to go second calc, number 5, intersect. And to intersect, you get your first curve, enter, second curve, enter, guess, have enter, and it tells us it's 109.86123. Put the glasses on for that one. Okay, I'm going to put this down, so 109.86123. And watch what we get over here by hand. So what they did is they divided both sides by 15. Both sides by 15, so they get 1/3 here. Then they take the natural log of both sides, so the exponent comes down because natural log of e is 1, brings the exponent down. Take the natural log of 1/3. What they do is they play with this natural log of 1/3. If you flip it, it's actually minus the natural log of 3. I don't know why they need to do that, but it just helps them over here. I would have just put natural log of 1/3 into my calculator. That would be okay. Notice we divide by negative 0.01, and that's how we get over here. And notice the negative is gone now. So this is what Q bar is. When you take natural log of 3 divided by 0.01, you get 109.8612, which is 109.86123. That's what we got. Okay, so you can do this with your graphing calculator or use the algebra, whichever you prefer. But this is going to be one of the limits of integration. And again, I recommend going out to about at least 3, maybe 4, because the homework questions are going to ask you to round to 2 decimal places, the nearest cent. So if you're going to round to 2, you want to go out to at least 3, and in this case 4 is probably even better. Okay, so what does that give us? Again, a little bit out of order, so we'll see this. So now we have, so that didn't work real well, but let's go through this. We have that the consumer surplus is the demand function minus P bar. Remember, P bar was 5. This was the function they gave us. P equals this. Notice our limits, we're going from 0 to, this is the value we found. It's where this function intersects with P bar. Okay. So it really just takes us back to finding the area between 2 curves. It's just a special application of it. Okay, so then you could do this by hand, which they've done, 0 to 109, this, they plug in 109.8612 for Q here, and these are the numbers they end up with. They also plug in 0 here and here. These are the numbers. They do the math, 405.69. How would I suggest doing that? That's perfectly fine to do it that way. However, since we've already got our graph, almost, well, we've got our 2 graphs, right? Let me move this over. So really, we just need to take y1 minus y2. That's what we were doing when we did area between 2 curves. So y1 minus y2, because we know which one's on top. So let's go ahead and do that. No, not second. Let's go to vars. Y vars function, and we want y1 first minus vars. I don't need to hit the second. Y vars y2 second. And what the nice thing is once you get used to doing this, getting the producer surplus will be the same process, but you'll graph it, you'll see the picture, you'll remember which one's on top, so you don't have to memorize, is this the one, the function minus the P bar, or is it the other one? You will visually see it if you do it this way. Okay. And now remember, I'm going to graph it, and remember we're going to have 3 graphs. So there's the 2, but notice where the intersection point is now, the x-intercept. It's basically, for the most part, just moved this triangular region down, making this sort of the x bar, or the x-axis. Sorry, just for, well, let's go ahead and do that. So what I'm going to do is I'm going to get the area under this curve, the black one, and you'll see it's really the same amount of area here, because it is really just this triangular area up here minus the rectangular area. So I go second calc, number 7, which is to integrate. Now remember, I've got to choose my correct one. This is why you may want to turn off, especially if you don't have color, you may want to turn off your other graphs. Okay, but I am now on this graph. It tells me I'm on the y3, which is y1 minus y2. I want as my lower limit, I want 0, so I put 0. I want as my upper limit 109.8612. So it's asking for the upper limit, 109.8612. Enter. Boom, look, I got 450.693. Move this over. 150.69, exactly the same thing. So you can do this all by hand if you want. There's this example here, or you can use a graphing calculator. So we do have both options. Just remember, the graphing calculator is required for this course. I know some of you have a different version than the TI-84, and this is the one I know how to use, so that's the one I'm going to present. I will, over the summer, learn how to use the others. I know that doesn't help you all much, but it takes more time than I have right now to learn how to use the other calculators, but I think that is important. Casio has a very good calculator at about half the price, but it's more difficult to use because I just don't have experience with it. Okay, so that's that. This is really just area under the curve. If you look at it that way, graph it, visualize it, you'll see the pieces. Okay, it's also got this special formula here, and when you're there'll be a test question like this. They actually give you the formula, so that's helpful. But just remember, this is just area under the curve. It's not anything really new, and that'll help us as we move into producer surplus. Just look at this as the same thing. They're going to give us a formula. We need to graph it and go forward. Okay. Yeah. So producer surplus. So this is a similar type graph. Here's this, and this time though, the formula, the function they've got, gives the price at which the producers are actually willing to sell it for. Okay. So the curve might go differently because, okay, out here, if there is higher demand, right? If there's higher demand right off the bat, they could sell it at a higher price. Or they would, with higher demand, they would be willing to sell it at a higher price. Okay, so with lower demand, they have to, this is sort of their minimum price. I guess that's what that says here. This is the price they're willing to sell it at. So if we could at the bat sell it at a higher price, say up here, some P bar is now above the initial price, what happens? Well, this is now their surplus. It's a producer surplus because, and again, it's going to be P bar minus S. So we subtract off this. This is the extra money they make. This is what they would have made here. And again, so this part is above a surplus. Also gets back to Riemann sums. Okay, so just like we were doing, so here's our Q bar. Oops, we went to it. So here's the surplus, right? If we look at this as a area between curves problem, it's just which curve's on top? Well, P bar is on top, so you take P bar minus S of Q. That's all we're doing. This is the top function. Just look at this as a function. It's y equals P bar. And we subtract off this part, and we get the surplus. Okay, we get the part on top, the area between two curves. That's all it is. And then we remember we generally are given this p-bar price, and what we have to find is where this intersection is, just like we had to do with area between two curves. Okay, because the integration goes from 0 until the intersection. 0 until the intersection. Okay, so in the problems, they'll give us this, and actually, they're going to give us this function. Now, this example, they give us sort of the inverse of that function, so they have to solve for it. But I'll just let you know, for the homework, we're going to start with the given function. Okay. And I remember doing these, I was started the other way. So here they are informed that, see, they're selling t-shirts. Okay, so you can kind of read through this. But what I'm interested in is the equations they give us. So they give us this equation that at a particular price, we will get a certain demand. And so our question is what if we sell them at $8? So this is going to be our P bar. So this is, we're going to start at $8 regardless, right? So it makes it actually in this form pretty easy to find Q bar, because we'll just plug the 8 in here and we'll find it. Right, P bar equals 8. But the supply equation, again, is sort of given to us backwards. We've got demand here, we've got price here. So they're going to have to go through and actually solve this equation. So they square both sides, get Q squared, and then they have to solve for P. So they divide by 400, and then they switch sides on us, right? What I'm telling you is you won't be doing this part because they're going to give us P equals, which is good. So P is equal to the function Q squared over 400 plus 4. Okay, and again, where our problems start is our questions will give us this and this. But typically in your economics problems, what they do is they give you the demand function at some given price. Again, in one sense, it's easier. You could just plug in the 8 here, and that'll give you your Q bar. Here, you plug the 8 in here, and you solve for it. So it just depends on which way you want to go about that. This one, a little bit easier. Okay, you plug in the 8, we'll get our Q bar. Q bar is 20 square root of 4, which is 40. So a little nicer. So then we're working with this producer surplus. Remember, this one is P bar minus the function. And again, we're going to get it by graphing it. And we're going to go from 0 to Q. Okay, so let's go ahead and graph this. Come back here. Now I'm going to show you something you can do. Since we've got y1 minus y2, what I'm going to do is I'm going to put P bar in y1. You could do whichever you want. So I'm just going to put 8 there. That's P bar. And then I'll put the function here, which is 20 x minus 4, square root of x minus 4, right? That's where that 8 came in. 20 square root of x minus 4. So that's our demand function. And then this is the one we're going to integrate. For right now, I'm going to turn it off because I just want to show you that the function y equals 8 is above this function. Let's see, what are we doing? We're going from about 8. It's going to be the higher. So our window, we don't have to go to 125. I'm not sure why we were doing that, but about 0 to 10 should do it. And our function, our y values, oh wait, price is our y value. So price, we want maybe 0 to 10. Our x value is actually what the demand is going to be, and we're just kind of guessing as you plug in. Well, we know it needs to be at least 40, so let's go to 100 so that we can see the whole graph. 8, 20, x minus 4, right? This is the function p minus 4. Oh, that's right. I have to go back. That's the problem. Is we're not graphing q, we are graphing this function here, q squared over 400 plus 4. All right, so you won't make this mistake because it's so p is our y value. We want q here, q squared. Okay. So we go with x squared. Let's clear it. Clear it. X squared divided by 400. Oops. Start over again. X squared. Come down to the line, divide by 400, and then add 4. Now, the way I've done this, it may not look like it, but order of operations, it will just take x squared divided by 4. This plus 4 is off to the side. Okay. You could put parentheses around it, but let's graph it now and see that's what I was looking for. Yes. Notice this is a surplus, the demand function at a given price, and so that's going to generate a surplus, this area up here between the blue and the red curve. Okay, and so as we see this, we'll get something that'll look a little different when we take y1 minus y2, but what we'll get is this area between the curve. Okay, what we need to do is find that intersection point. Watch, it'll be 40 because we've actually already found it, but I just want to show you, you can do this all with technology. Enter, enter, enter. There we go. X equals 40. That is our intersection point. That's our Q bar, right? So at $8, we would have sold 40 t-shirts, but we were willing to sell the initial ones at a lower price to get there. So we're going to, as a producer, we're going to make this much extra money. Okay. And what does that equal? Well, let's just go ahead and leave these on. I'm going to turn on this one. So I'm now taking y1 minus y2, right? Let's go back here. We're taking y1, which is just y equals 8, minus y2. We're going to go from 0 to 40. They're going to do it all by hand, but let's do it by the calculator first, and then we'll see what the answer that they get. Again, graphing it, so notice it just kind of makes it, this becomes the x-axis. It sort of flipped it over, but we're going to get that same area. So we go second calc, number 7. And again, we want to make sure we're taking the derivative of the correct function. So we either arrow up or down. I'm going to go, if you arrow up, you get there quicker because it kind of goes from y1 to the last one graph. So now look, I'm on y3. I'm off the graph, but that's the one I want to do. And I do the lower limit is always going to be 0. The upper limit is going to be 40. And the nice thing is you will graphically see it fill in 106.6667. So it's going to be 106.67. 106.67. 106. Let's put 106.67. Okay. So they combine the 8 and the 4 because this minus goes through. They go to the next step. They actually integrated for Q, and they're going to plug in 40 for the Q, 0. Well, they didn't show all the steps, but look what they got. That's what we got, right? From the graph, we got that same value. Okay, so view this section really just as an extension of area between two curves. Approach it the same because you're going to be given the values of the P equals and P bar. Graph the two, and again, just look at which one's on top. It'll help remind you whether you've got the consumer surplus or the producer surplus. And you'll be just fine. There's, I think, 3 or 4, maybe 5 problems. There is one last problem that is an applied problem. I'm going to ask you to do your best to set it up, to try to understand it, to think through it using your economics, knowledge of economics. I'm assuming most of you have had some economics, maybe not, but try that out because it's a nice applied problem. We'll take a look at that later in the week, probably Friday. I'll do another little video where I actually walk through how to get that set up. But do the other ones first, okay? And I think we're done after this. Okay, so we ended up earning an extra 106.67. Now it's money. I would have been willing to sell it at a lower price just to get the business, but I was able to jump at $8 and was able to make this extra money. Of course, this is all a lot of abstractions. Who really knows what the demand curve is? I'm going to let's keep it. So I'll post this PowerPoint as well as a separate PowerPoint if you find it helpful. If you don't have to look at it. And then this video. So we've got one more section after this, 14.5, and that's getting integrals to infinity or from infinity. And then we'll be in review mode. Take care. Be well. Bye.